Okay, so let's look at our surface water resources, starting with streams. So notice that we have different kinds of streams, what we call intermittent, ones that flow occasionally, have a lot of those down here in this part of Southern California. And then we have perennials, which flow constantly. The total stream flow stems from all the surface runoff plus subsurface flow and groundwater. And of course, the highest stream flow is going to be in the ITCZ, the Intertropical Convergence Zone down around the equator, as you can see here. So this is your groundwater resources. So here's the Amazon rainforest, Congo rainforest, and rainforests over here in Southeast Asia. And also remember warm water going up here, that's mirrored over here, what we call the Japan current, flows up here. And again, up here, it's the water still carries heat energy, warmer than the surrounding air. So we get lots of condensation that comes down in snow here in Norway. A lot of snow and rain up here in the Seattle area. Again, because of the warm water crossing the Pacific and going back across, using that heat energy, condensing, coming down as precipitation. So these are areas where we have large amounts of groundwater resources. Now, here in California especially, we erect dams, and that's how we contain the water surpluses. In China, they've just finished, well, they just finished a few years ago, what we call the Three Gorges Dam, the Yangtze River in China. It's the largest dam in the world. So here's when they started in 1887. So here was the river flowing through the mountains. So there's lots of orographic lifting, flows down on both sides into the river. Here's where they midway through the construction of the dam. Notice it's already expanding. You can see the dam right here, and here's the finished product. The dam is completely across. River flows change. They've had to displace, I think, almost 3 million people that had to move out of the area and into cities, which created a lot of problems for those folks. So that's dams there. Now, so we have streams, we have rivers, and then we have groundwater resources, which for many of us, that's the most important resource. The groundwater resources are tied to surface water supplies. The more precipitation that you have coming into the surface, the more they can percolate down through the layers and get down to what we call the groundwater recharge area. Okay, and it's heavily influenced by pollution, which we'll discuss here in a minute, also by extraction, we remove. Now, make sure you watch this water table animation over in the course module. So make sure you watch that. So here's the areas that in North America that are highest in groundwater resources. And as you would expect, where we get lots of rain, lots of groundwater. But here's one thing what you may not think of, and that's here in the Great Plains. This is what we call an aquifer, which we'll get into in a second, but it's these areas of underground water storage. And we have one here in California too, where the Central Valley is. And these are areas that used to be water bodies like oceans, and over time they were covered up with land through tectonic activity, but the water is still underneath, and you can drill down and extract that water just like you can oil. And again, very important for agriculture in this area, and also over here for us. And up here, all these aquifers, and again, a lot of that's just related to snowfall and ice. It sinks into the ground and stays there as groundwater. The world, again, where you would think up here in Russia, for example, all this is, a lot of it's frozen, but it's on the surface, but whenever it thaws, it percolates down. So in the aquifer, and there are lots of wheat growing in these areas because of the great amount of groundwater. And of course, through the ITCZ, this area right here. Now, excess water enters through what we call the zone of aeration. that area right at the top of the surface. So it will infiltrate the surface and then percolate down, pulled down by gravity. And the porosity of the soil, the size and shape of the particles, kind of determine how much water can get down to groundwater levels. So it's either permeable, where the water gets through, or what we call impermeable, where the water can't get through. So this might be sand, for example. This might be granite. When water percolates down, the pores between the particles fill up with water. And when they completely fill up, it's what we call the zone of saturation. The upper level of that zone of saturation is the water table. Now, aquifers are subsurface rock layers that are permeable to water flow. They can store vast amounts of water. Sometimes they're confined, meaning that they're impermeable above and below, so there's a lot of pressure exerted on the water. Or sometimes they're unconfined, meaning that it might be impermeable below, but permeable above, so the water can easily flow down and recharge the aquifer. And let me go back to the slides. So this is a prime example of an unconfined aquifer where it's recharged by the precipitation coming down. But notice how big it is, okay? I mean, these are huge. So here's what it looks like. Here's the top of the ground. So the precipitation comes down to infiltrates the zone of aeration, which is this, percolates down, pulled down by gravity. When you get down here, where the space between the pores completely fills up, we're at the zone of saturation. And the top level of that is water table. And notice this is what we call unconfined, meaning that the water can percolate down, reach the water table. It's impermeable below, but all this is unconfined here, so we can recharge it with surface water. But notice that if you have industries above that dump waste, or a landfill, or if you live in rural areas and have a septic system, for example, you can get a seepage that will actually infiltrate down too and pollute these aquifers. That's why it's so important to have environmental laws that protect against this. Now, these folks have drilled down a well, and that allows them to extract water for usage. And you can see there's a video on this in the course module. This is what's called the cone of compression. That forms this kind of cone area where we're extracting the water. So springs, stream flows, and wells, those are where the water table intersects with the surface. Groundwater can enter those stream channels and they can flow as surface water, but it's basically the top of the water table. And if you have a confined aquifer where impermeable above and below is trapped the water in there, there's pressure there, and that's where you get these artesian wells. They're under pressure and it forces the water up naturally, or you can drill down and it'll gush out, almost like you see these videos of oil wells, for example. So impermeable, but it's on the surface, we see it as a stream. This is the recharge area. Water will flow into it from the ground or from precipitation. It recharges this permeable layer, the confined aquifer, these artesian springs. An example here in Nebraska. Now, the High Plains aquifer, again, very responsible for growing a lot of soybeans and wheat in the Great Plains of the U.S. and also providing food for livestock, especially cattle. So this is called groundwater mining, where you drill down into the ground and then pump the water up to the surface. Now, if you take out more than what goes back as recharge, then you are getting into a deficit. And so this has become a threat on fresh water supplies worldwide. As the population grows, you need to grow more crops, need to provide moisture for more animals, food for more animals. So we're extracting more than we are recharging. And so check out the cone of depression animation course module. Okay, make sure you watch that. Now, the High Plains Aquifer has been overdrafted probably about 30 meters in some areas. It's by far and away our largest underground reservoir, and it's very, very important. This just gives you some idea. So here's the saturated thickness. Now notice it's thicker in Nebraska than it is down here in Texas. That's just because of the underlying rock. But it can be as much as 1,200 feet here in Nebraska. But here's where it's changed. Notice in some areas, the amount, the water table's gone down up to 150 feet in these areas in red. Up here, it's still, very much kind of the same. It hasn't decreased much at all. It's just stayed plus or minus 3 feet on the other side. This is because the rain and snow up here to recharge, and while they're growing lots of crops down here, this mostly goes for livestock grazing. It takes a lot of food to feed cattle, and so it's mostly alfalfa that's being grown to feed cattle, and that takes a lot of water, and so our surface or water level change has been greater in these areas. Here's 2015. Again, notice up in Nebraska, we're actually getting the surplus. It's actually rising up here, but heavily declining down here. And these areas were hit by a big drought too. And so you weren't getting the rain that was needed to recharge these areas. And so we have what we call an overdraft, and it has all kinds of problems, meaning that you just use up the water, but also as you take the water out, it leaves like a vacuum, a space where it was, and so the land starts to subside. And this is a problem we also have in the Central Valley of California, as you can see here. So the land was up here in 1925, and by 1977, it's down there. That's how much it's subsided. A pretty big jump, and as we keep going on, it'll keep subsiding as we take out more than we need. Other things that happen with this High Plains Aquifer, the Keystone Pipeline is going to go through this, and if there's any type of oil spills, as people fear, then you get pollution that's run into the water table, as you can see right here. And if there's any kind of industrial accident, remember, Nebraska actually has surpluses. They've actually gone up in their water, their recharge. But if you have any type of industrial accident, you get down and pollute the groundwater because it's so close to the surface. Okay. Let's stop here, and then we'll look at water supply.